say we've got this example. Wanna do electrical circuit. That's our topic. Electrical circuit. So there's parallel and there's series. In parallel, volt is the same. The current, total current equals to current of A1 plus current of A2. Resistance, total resistance equals to R1 plus R2. So in series, current is the same. So the volt, total volt equals to V1 plus V2. Resistance 1 over R total equals to 1 over R1 plus 1 over R2. Then we've got the formula for volt equals to IR, current multiplied by resistance, which current equals to volts over resistance. So I've got an example here. We've got 20 volts. We've got ohm resistance here is 80. Here resistance is 50, and resistance here is 30. I've just break it down to say this is 1, 2, 3. So you can see this is parallel to the whole of this. These two are series. So to start calculating it, everything, you just want to try to simplify this diagram into a simple thing which we can all understand. I'm gonna make this combine these two to be one. So it's gonna be resistance and resistance here. So this is gonna be like this. It's gonna be like this. Then we've got our 20 volt here. 20 volts. So I'm just gonna call this one, this 2. So here is 80 ohm. So we said we've got 30 resistance here and 50 here. This is in series. Oh, I made a mistake here. Yeah, the series here. Sorry, this is for parallel. This is for series. So in series, the total resistance RT equals to resistance for series equals to R1 plus R2, which is here I can just call it R2 plus R3. So R2 equals to 50, R3 equals to 30. So the total resistance for series equals to 80 ohm. So it means here it's also 80 ohm. That's the simplification of this. So to start with this, we must start with doing the resistance for the whole circuit, because I've already simplified it here. To find the resistance for the whole circuit, just for space. So resistance for the whole circuit, this is parallel. This is parallel to each other. So you must use the formula for resistance in parallel, which is this formula. I'm gonna write it down. Resistance, I'm gonna just say is total. This is for the total equals to R1, just like this one, plus 1 over R2. So equals to our R1 here is 80 here, plus our R2 is also 80. So we've got 80. So if you simplify it, it's going to be 80. 80 divided by 80 is 1. Then we get 1. 80 divided by 80 is 1. Then we write 1. So equals to 2 over 80. So this is equals to R over T. So we must swap them around, change them around. if we change R, the top, the bottom goes to the top goes to the bottom. So it's gonna be 80 divided by 2. And if you use the calculator, the answer will be 40 ohm. So this means the total resistance for this circuit, because this is the same. Our total resistance is RT equals to 40 ohm. So now let's calculate our total current. Okay, we've got the volt which is given. This is the volt which we given. Total volt equals to 20 V, because it was given. We've got this thing. To calculate the current equals to, we use the formula for current, IT equals to V over R. V, which is 20, over R is 40. So the answer here, I total equals to 0.5 A. So our IT equals to 0.5 A. So we've got a total resistance for our circuit, got total volts, and we've got total current. So but now let us check these things. They said in parallel volts is the same. So if you look, this is parallel to this. So volts for this side is the same as volts for this side. So we can summarize, say volt for here is gonna be, volt is the same. So we can say volts for this side is equals to volts for this side. So V here equals to 20, even here V equals to 20 volts. Again, this is the same, V equals to 20 volts. But here is 20 volts, this is 20 volts. This means there's also 20 volts going towards this side. But when you check now in series, the total volts equals to volt for 1 plus volt for 2. So this means these two are gonna share the volts, but the volts for this side is equals to the volts for this side. So because here we've got a resistance and the volts, let's calculate the current for this one. The current for, I'm gonna say I1 equals to V over R, which V is 20 divided by R, which is 80. So the answer is, I'm gonna use the calculator, 20. So I'm saying the volts is 20 divided by 80, which is 0.25 A. So the current for this side, which is I1, equals to 0.25 A. So we also need to calculate the volts for this side, calculate the current for this side. Okay, let's check the series. If it's in series, current is the same. So this means the current for this side and the current for this side is the same. But let's check again, if it's in parallel, the volts is the same. So this means we've got the 20 volts, we've got 20 volts here. But you must know that the current is not here, for the said current is the same. Okay, we've got our total current which is 0.5, and we've got current for A1, which is 0.25. So if we treat this like here, let me just write it down. Current here is 0.25, and the total one 80 equals to 0.5. So if we check the this one, the formula, current for the total current equals current for 1 plus current for 2. We can use this formula to get the current for this side. So to calculate it, I'll just say AT equals to A1 plus A2. So we already know that 80 is 0.5 equals to 0.25 plus A2. If we check, this is gonna be 0.5 minus 0.25 equals to A2. If we use the calculator, 0.5 minus 0.25 equals to A1 equals to 0.25. So we all know that this side, the current which is coming to these two is 0.25. So let's check that it says the current is the same. So this means, because we know that 0.2 is coming here and 0.25 is coming here, so the current is the same. So current for I2 equals to 0.25, I3 is equals to 0.25. So then now you can even double check it, because we've got the current here and the resistance. You've got the current here and the resistance. You can check if these volts of this side and volts for this side equals to 20. Let's try to calculate the volts for each. So volts for 2, this is the formula. Volts, this is the formula, equals to I for 2 and resistance for 2. So times in between. I for 2 is 0.25 times resistance, which is 50. So equals to, let me use the calculator, 0.25 times 50 equals to 12.5 V. So you can already guess, if you know that the volts here is V2 equals to 12.5. This is series. In series, volt for the total volt equals to V1 plus V2. Total volts, which is 20, that's the one coming to this side. Already this V2 is gonna get 12.5. Obviously this one is gonna get 20 minus 12.5. That's how we must check it. But we can use the formula for V3 just to check. V3 equals to I3 times, this is a formula to use, resistance V3. I3 is 0.25, resistance is 30, so equals to 0.25 times 30 equals to 7.5. If you can check again, just to check, VT equals to V, I'm gonna call it V, this one is V2 plus V3, so which is equals to 12.5 plus 7.5, which is equals to 20 volts. And if you check this V2, it's the same as this V2. So our answers are correct. Hope you can be able to see my answer later, to bring it closer so that you can check the answers. Hope you can see. This is how simple. This is mainly for grade 8 electrical circuit. Thank you. Please subscribe so that you can view more videos for maths and science. Thank you very much.